Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. In the previous lecture, we have covered the basics of the biological neuron and artificial neural network, and we have shown a basic model of the single unit threshold logic unit, also known as TLU. Today, we will try to cover the multiple TLU units in a model and what is a multi-layer perceptron model, and we will try to also cover how to train our models utilizing these kinds of artificial neural networks. So, let us start by continuing with the perceptron model. So, we have already understood what is a single TLU unit, right? Now, these single TLU can be utilized for binary classifications. Okay. So, how do we do that? We simply compute a linear function of inputs, and then if let us say output exceeds a threshold, we suggest one class, otherwise suggest another class. So, this is a simple implementation, right? But perceptron is usually a group of TLUs. Okay. So, how do these systems look like? We have created a simple model earlier, like 3 inputs with a single TLU unit and its step function, right? They were connected like this. These are the inputs x1, x2, x3, and this was the linear unit, then this was the step function. Okay. Now, what changed in these multiple? This is a single TLU. Let's say we have 3 inputs and we have 2 neurons. Okay. So, this is a single perceptron with 2 multiple TLUs. Multiple TLU model, and output of these 2 will be given to some other step function. So, they both have their own step function, and after that we will have multiple outputs. Okay. So, one thing that you should understand here is that I am trying to connect every input x1, x2, x3 with each of the neuron, right? So, these are your TLU1, TLU2, and I am trying to connect each input with each TLU. So, these are some kind of fully connected network, but it is also possible that some of the inputs get connected to only some of the neurons, and these are your step functions. So, these are your step function, okay, and this is output. 1, output 2. So this is a simple perceptron with multiple TLUs. Now when each TLU is connected with inputs this is known as fully connected layer or dense layer. So these are two famous terms that people usually use. Now here we have three inputs and two outputs, right? So this kind of system, this multiple TLU that we are showing here, this is possible to classify inputs into two distinct classes. So let's say you have more than two classes, then what you need to do is you just need to increase one more neuron here and it will also get connected to every input, right? So and again a step function and an output 3. Now these kind of systems can perform multi-level or multi-class classification. So what are these multi-level classification? So an example of these multi-level classifications could be movie tagging. Like you are seeing a movie and you want to know what are the different tags that can be used on a particular movie. So a movie genre could be comedy, drama and thriller, right? So these kinds of multiple labels classifications for each movie could be an example of these kind of classifications. But this multi-class classification is different. So here we assign exactly one class to our inputs. Okay. So let's say you have a large amount of data set of images and you are just trying to assign whether it is a cat or a dog. So your classification algorithm will output either cat or dog, right? So here we are not trying to assign multiple labels. We have multi classes of labels, but we are assigning only one class. Okay. Now we understood what is a perceptron model. Now we need to understand how we are going to train these kind of models. Okay. So perceptron training is based on Hebbian learning. And these Hebbian learning inspired the training of perceptron algorithms. Now Hebb proposed this. proposed cells that fire together, wire together. Okay, so he proposed for biological neurons, right? Biological neurons triggering other neurons. They will have strong connections. So, if you remember that there were synaptic terminals in simple biological neuron, and if they are sending more neurotransmitters to a particular another neuron that is connected to it, then the connection between those two neurons gets strong. So, based on this inspirations, we will start training our perceptrons. Okay, so steps in training, something like that. So, we will first start with the inputs and input given to perceptron. Second, we will make perceptrons, will make predictions, and wrong predictions will get tweaked by changing the connection weights. Okay, now these things are based on this simple equation, like let's say w I comma j in the next step of training is based on the w I comma j. W is the weight here of the previous step plus eta yj minus y hat j into x of I. So, for a particular next step, the weights will be based on the previous weights plus this eta is the learning rate. Eta is the learning rate. Okay. Y of j is the target output, actual target output. Y hat j is the evaluated output. Of the jth neuron. So, this equation will help us train our model by tweaking the weights at each step, right? And this single layer perceptron is limited. So, that is why we will utilize multi-layer perceptrons. They can solve complex tasks. So, if you remember, a single TLU unit will not provide much insights to your data, but multiple layer perceptrons will be useful for your training task, right? Now let us understand how to create a multiple layer perceptron model. So we have already looked into a single layer perceptron model. Now let's try to develop these MLPs. So let's say we have two inputs, and let's assign 4 neurons, 1, 2, 3 and 4 neurons in our first layer, okay, and only 2 neurons in our next layer, and finally 3 neurons in our last layer. Now these are connected so these let's say these all are dense layers. We have already introduced what is a dense layer. These are fully connected layers. That means each unit is connected with all other units in the next layer, right? So I will not show you by creating these arrows because it will waste the time, but here what I want to let you know is that each neuron contains both things like linear function z and your step function. So I am not showing you these separately now in this model because we have increased the number of layers. So each neuron will have both of these things, right? Again, this layer will get connected to other layer of the neurons, and the last layer will also be connected. All of these layers are fully dense. Now in this layer, in this model we have 3 outputs: output 1, output 2 and output 3. Okay. So now let's understand different things about this MLP. So these MLP contains broadly 3 kinds of layer: input layer, hidden layer and output layer. So layer here means the series of neurons, like this one. These series of neurons will create a single layer. Okay, this is another layer and this is the last layer. So input layer holds the input instance for the model. Output layer contains TLUs in a single layer. Layers close to input layer are termed as lower layers. Okay, and those that are close to output layers are termed as upper layers. Now signal flows only in one direction. So what does this mean is you start computing from your left to right here in this model. Then it is known as feed forward neural network. FNN. When we introduce deep stack of hidden layers, then it is known as deep neural network or deep learning. So this is the most widely popular term, deep learning, and now you should understand that once you start increasing these number of layers, like here we have only two layers between input and output. So then we can let's say we have 2000 layers between input and output, then it will be a very dense network of layers and it can be utilized for deep learning. So let us summarize the steps in training once again. We have a forward pass. In this step, what we do is we send our input to the hidden layers and then to the output layers. In this stage, each neuron computes the value of z, that is a linear function which can be denoted by wx plus p, right? And the output of this uh, evaluation will be sent to our step function. Step will utilize the z as an input, and let's say this is the h gets stored in another function. So forward pass stores activation and outputs for error calculation at later stages, right? In the next stage, we have loss function. At this stage, we compare predicted output with our target or true target values. So we can do this by using this mean squared error as an example, right? These loss quantifies amount of deviation from the target in the layered network. So this layered network is our own design. We can tweak this. In the last stage, which is also known as backward pass. Here we compute error gradients and we propagate the error backward using chain rule. So this backward pass is very important in all these steps. Why? Because at this stage we tweak the weights in the network to reduce the deviation from the target. Okay. So forward pass computes predictions and backward pass adjust weights. Now this backward pass is also known as backpropagation step, and in this step we handle instances in mini batches. Why? And because the complete training happens multiple times. This is known as the epoch. Each pass is known as the epoch. Okay. So forward pass each mini batch provides predictions and values get stored for the backward pass, right? Then we evaluate the loss function. After that we evaluate the backward pass by computing the contribution by each unit utilizing chain rule. After doing these three things, we repeat the above steps to the previous layer until we reach the input layer. We also perform gradient descent to tweak all the weights connection using the errors that each gradient So these are the overview of the steps that are utilized while training our perceptron models, and in the next lecture we will try to show you how we can implement the basic multiple layer perceptrons model for our diamond dataset, which we have already discussed in our previous videos. Thank you.